Hello everyone, hope you're doing well. Hopefully this is the last time I have to do this. I'm hoping to be back on Tuesday of next week. Hopefully that first part went well. I'm making this before I actually kind of look over everybody's stuff. Just kind of made this ahead of time. So I'll check things out and see how everybody is, and we'll go from there. The first part of what I have left here in this section to talk about, I think, is a little easier and could even help you with some things in terms of quadrants. So what it is conversion between degrees and radians. To do that, let's think about what we already kind of looked at in terms of our quadrants. We know all the way around is 360 degrees. We also know it's 2 pi. So they're equivalent. Okay, they're equivalent. Well, we can kind of narrow that down a little bit. If you think about it, like halfway around is pi radians, and halfway around is 180 degrees. So really all I did is divided both sides by 2. So we're going to come up with a conversion factor. Okay, so when you want a conversion factor, you kind of want to know what is one of something equal to in the other. So in other words, I want to get 1 radian here. And what's that equal to in degrees? Now I don't want a decimal. We're going to have this in terms of fractions and things. So how did I do that? Well, all I did is I divide both sides by pi. Okay? So if I divide by both sides by pi, I get 1 radian, because pi divided by pi, and I get 180 over pi. Okay? So that's one conversion factor. Okay? And that one we use to change radians to degrees. Now, a conversion factor, you use those in science a lot. And when you use them in science, you multiply something by that conversion factor. I'm trying to think of something right off the top of my head. 1 mile is 5,280 feet, so you might have had a 1 over 5,280 feet as a fraction. Okay, so those are the kind of things. All right, so then what if we want to know going from degrees to radians? Well, in that case, I need to know what 1 degree is in terms of radians. Okay, well, in that case, then I'm going to divide by 180, because 180 divided by 180 is 1. And then I'm going to divide this side by 180. So that gets me pi over 180 radians. Okay, and so that's my conversion factor for degree to radians. Now, when I say conversion factors for these, what I mean is we're going to take, let's see if I can find a different color, and multiply by this or this. Okay? All right. So let me show you. Real simple. This one's going to convert to degrees. So what does that mean? That means I'm going to multiply by 180 over pi. Okay? So I'm going to take pi over 6. It's all about fractions. Okay? So this is all about fractions. We're not using a calculator here to get a decimal or any of that kind of stuff. You can use a calculator to do some work for you. But what's going to happen if you do this right, and this is how I remember the conversion factors, by the way, because one's 180 over pi, one's pi over 180, is I know I don't want pi in my degrees. I want them gone. So what happens is those cancel, and then I get 180 over 60. So that's one way to do it, right? 180 over 6, which is 30 degrees. The other way, you could also do some cross-canceling, right? 130, and you get 30 degrees. Okay. Maybe you want to pause and try number 2 on your own, and then press play and watch the solution. So 3 pi over 2 times 180 over pi. Again, pi's cancel. You could, multiply here, 3 times 180, and then divide by 2, or you can do some cross-canceling, 190, and that gets me 270 degrees. Oops, that didn't quite very well. Okay? Right? So again, that's conversion. Now, how did I say this could help you with yesterday? Well, the radian ones are the hardest ones. degrees I think most people get. So if I give you a radian, you're not sure what quadrant it's in, you could convert it to degrees and then easily answer that. So for example, you know, this down here, this is in quadrant 1. Well, that means pi over 6 is also in quadrant 1. Okay, number 2 is not a quadrant; it's on an axis, so that's not a helpful one. Okay, all right. So you could use that as a way to kind of answer that question. All right, convert to radians. Same thing, but now we're going to multiply by pi over 180. Okay, so we're going to take 60 over 1 times pi over 180. You know, and again, we have to do some reducing. I want to leave this as a fraction. I don't want a decimal in this case. Okay, so how do we reduce that? Well, you know, the zeros can cancel out. 6 over 18. This becomes pi over 3. You could also do it back here. You can go 1 and 3. It's pi over 3. So again, you might want to pause and try this one. Okay, so 150 times pi over 180. Well, if I was doing this one and I'm doing some cross canceling, you cancel out the zeros because 10 goes into it, and then what goes into 15 and 18? Well, 3 does. So 5 and 6, which then gives me 5 pi over 6. All right, good. So I got a couple more here. Attempt them. I'll just go through the solutions and afterwards again. You may want to pause and do that. All right, so negative 3 pi over 4 times 180 over pi. Pi's cancel. Let's see, 4 once, 4 into 180 is 45. Negative 3 times 45 is negative 135 degrees. Okay. 7 pi over 3 times 180 over pi. Cancel, cancel. 3 into 3 once, 3 into 180, 60. So then we get 7 times 60, or 420 degrees. So my point there is we can get negatives, we can get things bigger than 360, all of that. All right. Couple more examples. Convert to radians. Excuse me. Again, you might want to pause and come back. So 45 times 1, or pi over 180. Okay. So sometimes simplifying fractions is a little more challenging. You know, I might break this one down. I'm going to use a different color here. So like I know 5 goes into this 9 times. So 5 goes into that 36 times. Oh, but 9 goes, I can go even further. 1 and 4. And so then that gets me negative pi over 4. If a problem starts as a negative, it has to end as a negative. All right, and then 215 degrees, same idea, 215 times pi over 180, well, that looks like 150, let's try that again. Okay, and so I would look at this one and say, let's see, 5 goes into this 36 times, 5 goes into that, what, 43? I think that's right. Yep. Can anything else go into that? Well, let's see. 36 is even. It doesn't go into 43 because that's odd. 3. Well, 3 doesn't go into that. 4. No. 9. No. And actually, if we think about it, 43 is prime. Nothing goes into it. So that just stays as a big, ugly fraction. Okay. All right. The only other thing with this is there's a couple examples. I think I'll just squeeze them in down here. Is if we're going from, let's say, first of all, we're going to go from radians to degrees, and I give you the radian, like, let's see, I'm going to give you the radian here as 2.21. Okay, so that's the radian, and I want to change it to degrees. Alright, so I'm going to take 2.21 times 180 over pi. Now, here's the thing. The directions will say this a little clearer. Is, you know, it's basically what's happening is I started off as not something in terms of pi. I started off with decimal. That means I want to end as a decimal. So if my radian's a decimal like this, I want my degrees as a decimal as well, because the pi's are not going to cancel. So what does that mean I'm going to do? Well, I'm going to use pi equals 3.14. So I'm going to type in a calculator, 2.21 times 180 divided by 3.14. So I'm going to pull up the calculator here. There we go. Just we don't need it that big. So I would go 2.21 times 180 divided by, and I can just use the pi symbol, or I can use 3.14. It doesn't really matter. You get a slightly different answer, but it's the same thing. So what is that? 126.62 degrees. Okay, so if the problem states that, and then vice versa, if I give you something as, let's say, 19.81 degrees, and I want it in radians, I'm going to look for an answer that looks like this. So I'm going to take 19.81 times pi over 180. But again, I'm going to use my calculator. Type in 19.81 times pi divided by 180. Okay, and I get 0.345 radians. Let's go 0.35. Okay, and that's in terms of radians. I have no symbol on it, so that way I know it's not degrees. Okay, and so that's the idea there. If things are in a decimal, you're going to keep them as a decimal. We don't do that up above. If things are nice whole numbers, I want them as fractions or nice whole numbers. Okay, I'll assign something here with this as well, and hopefully we can catch on to that, so that hopefully next week we can kind of review a little bit. Make sure everybody understands what's going on, and then move on. All right, take care.